In this video, I'm going to explain how Prodigy stores images that you are annotating, and in doing so, I also hope to show you a trick that might save you on a bit of disk space. As a motivating example, I've got a folder over here with lots of images of my cats, so I'll use that as an example. And to get things started, I'm going to start Prodigy using the image manual recipe. The name of the dataset is going to be kittens. I'm giving it the image folder, and the names of the labels are Noah and Sok because those are the names of my two cats. The labeling interface now looks like this, and I'm just going to label Noah, and I'm also quickly just going to label Sok. Great. So this will do as an example, so I'm going to hit accept over here. And with this example accepted, I can now hit this save button over here to actually make sure that this image is stored in the Prodigy database. So just hit that. And now we can go back to our terminal so we can inspect the data. So I'm back in Visual Studio Code now, and I'll just hit Control-C to shut down the Prodigy server. And what I can see now is that I have saved one annotation in the SQLite database locally, and in particular that I have a dataset called kittens that has this one little annotation. So I'm going to now inspect the annotations itself, which I can do with the dbout command, and I am interested in looking at the annotations from the kittens dataset. When I run this, a lot of stuff gets printed into the terminal, so just to make it easy on myself, I'm just going to push this into a file. And that way I can open it up from VS Code. So what does the data look like here? Well, it seems like we have some sort of a JSON blob where we have a key called image, and then we have something that seems like a base 64 encoded image. And this is basically the text representation for the image, which is just a way of storing the image in a text file. And we can see that this is actually a lot of text, because again, we are storing the entire image in text here. But if I just scroll all the way at the bottom, then I can see that at some point the image base 64 text ends, and that I then have some meta information, as well as an input hash, a task hash, and most importantly, I can see that there are some spans, which refer to the shapes that I've actually drawn inside of the image. Now, what's convenient about this is that this example is self-contained. Given this large base 64 encoding, you can completely reconstruct the image. So Prodigy is using a very sensible default here by storing the entire image in text like so. The only downside is that this will also cost a little bit of extra disk space. You are going to have to store the entire image. And in this particular case, because I do know that this image actually came from a file that I already have on disk, then I might not need to actually store this entire string. So let's rerun Prodigy now, but now with an extra setting. One that's going to make sure that we don't save this entire image in every single annotation. So I'm going to be restarting Prodigy now, and I'll be using the same command, but with this one extra setting. Remove base 64. And it's going to be this one setting that's going to prevent this entire string from also appearing in our annotation database. And just for good measure, I'm also going to be storing this in a separate data set. So I'll just give the data set a new name. I'm going to call this kittens light because we are going to be storing lighter data. So let's run this. The server is running, so let's label. I've gotten my familiar labeling interface again, so I'll just select Noah real quick, and I'll select Sok real quick. Once again, I'm going to be hitting accept. And after that, I'll be hitting save. The annotations are saved now, so I can go back to the terminal. I can shut down the server once again. And once again, I can use the dbout command to take my kittens light dataset and to move that into a new JSON-L file. And let's inspect that. Now when I inspect this, I can indeed confirm that there is no base64 encoded image in here. This is just a line of JSON that has all sorts of information that's useful. And once again, I can see my spans over here that contain a label for Noah with a X, Y, height, and width parameter. But I can also see I've got my label for sock. So all the information that I'd like to have in my annotation is definitely still in here. The only difference is I'm not storing the entire image. I am merely only just storing the reference to the original file. This can save a whole lot of disk space, so that's a nice trick to keep in the back of your mind. Of course, do remember that if you are going down this route, you do need to make sure that you carefully store the original images, because otherwise you might be at risk of losing data.